Hi all, here we're going to talk about binomial theorem, and what binomial means is two terms. Let's say we have 2x plus 7y to a third power, or 7x squared minus 3b to the fifth raised to the 13th power, or 18xy plus 147ab raised to the fifth power. Now, binomial theorem has to do with expanding these parentheses without having to rewrite them as, let's say here, 3 sets of parentheses and distributing, or 13 sets of parentheses, and at some point there's 13th one, or 5 sets of parentheses, because this would take a lot of time, and binomial theorem is pretty much a pattern that will save you a lot of time. Binomial expansion has a pretty cool pattern. Let's say we have x plus y as our two terms inside of the parentheses. If we raise this to 0 power, anything raised to 0 power, we would have 1. Let's say our next exponent is 1, so the parenthesis will simplify into x plus y. And there is nothing else to do with this. So this will be our next answer, x plus y as is, pretty easy. Now that we get higher exponents, we actually need to do a little bit more work. If we have to raise this binomial to a second power, this will be x plus y times x plus y. And after we distribute x times x, we have x squared. This will be xy plus this will be xy plus y to the second. So our next answer will be x to the second. We have 1xy plus another one plus 2xy plus y to the second power. Let's say next exponent is 3, which will be x plus y times x plus y times x plus y. This parenthesis times itself 3 times. We just did work for multiplying these two that amounted to be x to the second plus 2xy plus y to the second. We need to distribute this x plus y, so we get x to the 3 plus x squared y plus these two will give us 2x to the second y plus 2xy to the second plus xy to the second plus y to the third. This will simplify into x to the 3 plus 1x squared y plus 2 more. We have 3x2y, 2x y squared plus 1 more. We have plus 3xy squared plus y to the third. And without using the actual calculations, I will expand x plus y to the fourth without actually doing the distribution and multiplying through. This will be x to the fourth plus 4x to the 3, y to the 1, plus 6x to the 2, y to the 2, plus 4x to the first, y to the third, plus y to the fourth. And the reason this was so easy for me because I know the Pascals triangle. Now the thing you need to notice here is that in each term the sum of exponents is 4. The coefficients actually follow a really nice pattern. So first one and the last one is 1. And it is a Pascal's triangle that has been discovered law by Pascal. If you're raising a binomial to 0 power, the result will be 1. If you're raising the binomial to the first power, the coefficients will be 1 and 1 for each of the terms. Now the cool things become once you start raising to the second power and up. The leading numbers will always be 1, and the next number will be the sum of these two, which is 2. Then the next corner will also be 1. For a third power, first coefficient will be 1. This coefficient will be the sum of 1 and 2, which is 3. This coefficient will be sum of these two, which is 3. And we have 1 at the end. For fourth power, we'll have 1 in the corner. Next coefficient will be the sum of these two, which is 4. This one will be 6. This one will be 4 again, and this will be 1. And you can take this pattern to as high of power as you need. So you can take it to the first power. So you will have 1. The sum of these is 5. Sum here is 10. Sum here is also 10. Sum here is 5 and 1. Sixth power is 1, 6, 15, 20, 15, 6, and 1 again. Now, if you have a binomial that is raised, for example, to the 7th power, you may not want to develop this triangle. And this is where binomial theorem comes into. So, in order to calculate a binomial coefficient, which will be represented this way, and the actual calculation will result into the top number will go into numerator, which is 8 factorial. Then we will have 3 factorial, and the difference between those two, 8 minus 3 factorial. The fastest way of simplifying this would be to see what happens in the denominator. So we have 3 times 2 times 1 times 8 minus 3 will be 5 factorial. Then we have 8 factorial can be written as 8 times 7 times 6 times 5 factorial. So something divided by itself cancels out. 3 times 2 is 6. 6 divided by 6 cancels out. And we just have 8 times 7, which amounts to 56. Let's apply binomial theorem here. If you want to apply the formula, n is 3, a is 2x. If it's multiple things, you put them in parentheses. B will be negative y to the 4th. Negatives and exponents, you want to keep everything inside of the parentheses. So in order to expand this, first term will be the exponent will go on top, 3. The count begins at 0. We will have first term, which is 2x, raised to the difference between top and the bottom number, which is 3 minus 0, 3, times the second term, which is negative y to the 4th, raised to the bottom number, which is 0. The next binomial coefficient will be exponent of the parentheses goes on top. The next number on the count is 1. You just keep on counting from 0 until you reach the exponent value. The first term was 2x, and you raise it to the difference between the numbers. The next number will be raised to the bottom exponent, which is 1. The next binomial coefficient will be 3, 2. We have 2x raised to the 3 minus 2 power, and negative y to the 4th raised to the bottom exponent, 2. 3. Next counting number is 3. 2x to the 3 minus 3 times negative y to the 4th raised to the bottom power, which is 3. So this will be 3 factorial out of 0 factorial, 3 minus 0 factorial, times 2 to the 3, x to the 3. Anything to the 0 power is equal to 1, plus 3 factorial out of 1 factorial, 3 minus 1 factorial. 3 minus 1, this is a power of 2, so we have 2 to the second, x to the second, times negative y to the fourth, plus 3 factorial out of 2 factorial, times 3 minus 2 factorial. 3 minus 2 is 1, so times 2x, times negative times negative, we have positive y to the 4 times 2, 8. And last term will be plus 3 factorial out of 3 factorial times 3 minus 3 factorial. This is power of 0, so 2x becomes 1. So we will just have times negative times negative times negative negative y to the 12. 4 times 3 is 12. So this is 1, this is 1. We have 3 out of 3 factorial. First coefficient becomes 1 times 2 times 2 times 2, 8x to the 3 plus. This will simplify into 3 times 2 times 2 is times 4, x to the second times negative y to the fourth. This will simplify into 3 also, times 2x y to the 8 plus this will be 1 times negative y to the 12. And just a little bit more of simplifying. We have 8x3 positive times negative minus 12x2y4 plus 6xy8 positive times negative minus y to the 12. And this is our solution. Here you have to find third term of this binomial. So the only tricky thing about this problem is to figure out the binomial coefficient. Now the top number is always the exponent of the parentheses. Then you have first term, which is 3x, second term, which is 2y. For the second exponent, you need the bottom number, and for the first one, you need the difference between those two numbers. Just remember that we begin our exponent count and the bottom coefficient count from zeros. So if we are asking for a third term, and I believe in your textbook they would refer to it to, if they call this r, you would set this being as r plus 1 equals to 3. Or you can just remember that if you start at 0, the count is always 1 less. So if you are asked to find third term, the bottom number will actually be 2, 1 less. And now it's easy. This exponent will be the difference of two numbers, and this exponent will be the bottom number. So now we have 7 factorial out of 2 factorial, 7 minus 2 factorial times 3x to the 5 times 2y to the second. Let's do the bottom of this factorial. We have 2 times 1 times 5 factorial. And let's expand numerators. So we have 7 times 6 times 5 factorial. Distribute the exponent. We have times 3 to the 5, x to the 5, 2 to the second, y to the second. Something divided by itself cancels. 2 goes into 6 3 times. So this binomial coefficient is actually 7 times 3, which is 21. 243 times 2 to the second is 4, x5, y2. 21 times 243 times 4 will be 20,412, x5, y2. This is our solution. That's all.